when we multiply out these binomial brackets, we have x plus m, x plus n. How does it affect the b and c values in the quadratic? Okay. And bear in mind that this middle term bx is going to be from two parts along the diagonal. So the prediction that we should make is that the m plus n should be equal to the b value. When we look at our multiplication here, x plus n, x plus m, we get our x squared, so we get nx mx. So these two together, then the sum of these two adds up to the b value. And then when we look at the c value comes from this bottom right hand term. And we know that m times n is going to give us the c value, which is our constant term. And so I'll just highlight that as well. So the b comes from there. And our c value then must come from the product of these two here and here. Okay, so that's our product. The m, the constant term n and the constant term m is going to multiply into mn. So when we multiply this, we should expect that our middle term should be 4x and our constant term should be 3. So when we multiply this out again visually, this is going to be compelling. If we have our visual for this, we have x plus 3. Here we have x plus 1. We're going to end up with an x squared here. And we can see that this one term is going to give us 1x in the bottom left-hand corner. This 3 ones here is going to give us an area of 3x in the top right-hand corner. Okay, and these terms are like terms. They're the same shape, so they're like terms. So we're going to end up with x squared plus 1x plus 3x, and then in the bottom right hand corner, we're going to end up with 1 times 1 3 times, so we're going to end up with 3, and this is going to be the product of 1 times 3. So that grouping of 3 here comes from the 1's tiles here and the 1's tiles here. So when we combine the like terms, then there's going to be how we combine that middle. That middle term comes from combining these two like terms along the diagonal here. And then the plus 3 is just going to be plus 3, and that's our factor term. That's our term that we get from multiplication. So we get 1 times 3, which gives us that 3 here. Again, I'll highlight that there. Okay, so this is our 3 here. Okay, so we can distribute this out as well. So we should understand how this connects to the distribution. So when we do x times x, we get x squared. X times 1 gives us the 3x's, or sorry, the 1x down here. 3 times x gives us the 3x's here, and that gives us 3 times 1 gives us the 1's. So just highlighting that again. This distribution here and this distribution here gives us the 4x's when we add it up, and the 3 times 1 gives us the 1's that we get at the end here. So we'll do the distribution first here and see what we end up with, but we should make a prediction again. We should expect our middle term to be the sum of 2x minus 2x and minus 3x, so it should be minus 5x, and the constant term should be the product of negative 3 times negative 2. So as I do my distribution, I'm going to end up with x squared minus 3x minus 2x. Negative 2 times negative 3 is going to be positive 6. So there's my 4 terms. Okay, I'm going to combine my like terms. So what does that look like in our area picture? And again, it's really important to have a visual for this. So these are going to be our negatives, so I'm going to shade those differently. So positive times positive gives us our positive x squared. So there's our positive x squared. Negative times positive gives us negative x. Okay, so we have 3 of them here. That's where the 3 show up here. And then this x times these -2 are going to give us 2 negative x's along here. Those are like terms, so we're going to combine those together. Again, these are like terms, and they show up along this diagonal. And then the product of negative times negative is going to give us three ones, and -2 ones here is going to give us positive, so we just have to make sure we have our signs correct. And we're going to get our +6 there. Okay, and again, we get a product of the 2 times 3. Okay, so that number is based on a product, and this sum of -3x minus 2x is when we add these like terms together along that diagonal.